Class 11 Chemistry, we were discussing Unit 11, the P block elements, and in this video we'll discuss about occurrence, atomic and physical properties of group 13 elements. Group 13 elements, the boron family. These are the members: boron, aluminium, gallium, indium, thallium and nihonium. Symbol BALGAINTLNH. Atomic number: boron 5, aluminium 13, gallium 31, indium 49, thallium 81, nihonium 113. Boron is typical non-metal. Aluminium is metal but shows many chemical similarities to boron, and rest of the members, gallium, indium, thallium, nihonium, these are the typical metals. Occurrence of group 13 elements. First come to the boron. Boron is a fairly rare element, mainly occurs as orthoboric acid H3BO3, borax Na2B4O7.10H2O, and kernite Na2B4O7.4H2O. In India, borax occurs in Puga Valley, Ladakh and Sambar Lake, Rajasthan. The abundance of boron in Earth's crust is less than 0.0001% by mass. There are two isotopic forms of boron called B10, that is mass number is 10 and its abundance is 19%, and B11 and its abundance is 81%. Aluminium is the most abundant metal, remember it, most abundant metal and third most abundant element in the Earth's crust, 8.3 by mass, after oxygen 45.5% and silicon 27.7%. It means most abundant element in the Earth crust is oxygen. Second most one is silicon, and third most element is aluminium. That is, if we compare the element, then aluminium is the third most. But if we compare only the metal, then aluminium is the most abundant metal in the Earth crust. Bauxite Al2O3.2H2O and cryolite Na3AlF6 are the important minerals of aluminium. In India, it is found as mica in Madhya Pradesh, Karnataka, Orissa and Jammu. Gallium, indium and thallium are less abundant elements in the nature. Nihonium is a synthetically prepared radioactive element with a half-life period of 20 seconds. Now come to atomic properties of group 13 elements. First of all, electronic configuration. The outer electronic configuration of these elements is Ns2 and P1. Now you can see this is boron, this is helium 2s2 2p1, aluminium, this is neon 3s2 3p1, gallium, this is argon 3d10 4s2 4p1, indium, this is krypton Kr 4d10 5s2 5p1, thallium atomic number 81, xenon 4f14 5d10 6s2 6p1, and nihonium 113, radon 5f14 6d10 7s2 7p1. Okay. Now, if you analyze the electronic configuration, then you can see boron and aluminium have noble gas core. Core means inner electronic. Okay. This one is the outer most electronic configuration, and this is called inner core. Okay, core. So boron and aluminium have noble gas core like helium and neon. And gallium and indium have noble gas plus 10d electrons. See, this is gallium, argon, this is 3d10, and indium, krypton 4d10. This is inner core. Thallium and neonium have noble gas plus 4f electrons plus 4d electrons core. See this one. This one. This is for neonium. Noble gas plus 5, that is f plus d electrons. Next one is atomic radii. In general, on moving down the group, atomic radius is expected to increase due to increase in number of cells. Now, Let us see this table. Atomic radius of boron is 88, aluminum is 143. This is the increased. But if you compare the gallium, this is 135. This is less than aluminum. Okay. Then again there is an increase, and again for thallium this is increased than indium, but this increase is again very less. Atomic radius of gallium is less than that of aluminum. Now what is the reason? Because the presence of additional 10 d electrons, we already discussed in the electronic configuration, offer only poor screening effect. That is also known as shielding effect. That is poor shielding effect for the outer electrons, which results in increased nuclear charge in gallium. Consequently, the atomic radius of gallium, that is 135 picometer, is less than that of aluminum, 143 picometer. For the same reason, we can explain that the less increase in the atomic radius of thallium due to the presence of inner d electron as well as f electrons, which offer the poor shielding effect. So, nuclear charge is increased. Ionization enthalpy. See this table. General. If we see the general, this is a decrease. Ionization enthalpy. Okay. But again, the decrease from B to Al, see this one, B to Al, is due to increase in size. But again, this is increase. The ionization enthalpy value of gallium is more than aluminum. Reason is due to poor screening effect of inner d electrons. Okay. In the same way, for thallium, this is again increased. The ionization enthalpy value of thallium is more than indium due to poor screening effect of inner f electrons. Electronegativity. Down the group, electronegativity first decreases from boron to Al and then increases marginally. This is because of the discrepancies in atomic size of the elements. See, this is decreases, then this is increase, but this is very less increase. Physical properties of group 13 elements. Boron is non-metallic in nature. It is extremely hard and black colored solid. It exists in many allotropic forms. Due to very strong crystalline lattice, boron has unusually high melting point. Rest of the members are soft metals with low melting point and high electrical conductivity. Gallium, with unusually low melting point, only 303 Kelvin, could exist in liquid state during summer. Its high boiling point, 2676 Kelvin, makes it a useful material for measuring high temperatures. Actually, in the lower class, in the 10th standard, we have discussed that gallium is the element which melts when kept on our palm, because its melting point is less than our body temperature. Okay. Density of elements increases down the group from boron to thallium. Thank you. Subscribe my channel to get the next video from this chapter. In the next video, we'll discuss the chemical properties of group 13 elements.